Alright guys, here's a couple of videos to go along with the work that you have to do for section 5.5. I'm going to start off with example 1 on the front page for part 1 with the double angle identities. It's the example that says if you're given the sine of theta and it's negative 12, move my screen a little here, negative 12 over 13 between 3 pi over 2 and 2 pi. So I already started drawing this triangle here. I'll finish up in the fourth quadrant, labeling my sides, negative 12, 13 for the sine, and then we can fill in 5 for our 5, 12, 13 triangle. So from here, we can already find our sine, our cosine, and our tangent of, remember, this angle here is theta. All right, so I have that, and we just need to use those double angle identities to get the answers we need. So the first one would be that sine 2 theta, and I'm going to use the first formula that we came up with, which is 2 sine theta cosine theta, and just fill in. So you guys can watch, I'll just write this out. All right, so that's it. I'm going to freeze it there and just go back. So you can see here, let me grab a color, that I took the sine from my triangle, which they gave us, negative 12 thirteenths, and the cosine from my triangle, 5 thirteenths, and just multiplied them all together. It's pretty much that simple for the rest of these. Just have to remember those formulas and how we got them. So you can watch the rest of this. For our cosine, I'll slow it down a little bit. And I chose to use 1 minus 2 sine squared theta just because they already gave us the sine, and that way I didn't need to use more than one trig function. Alright, so when simplified for that one, I ended up with negative 119 over 169. And I think the easiest way for the tangent would just be to use sine 2 theta over cosine 2 theta. So I took negative 120 over 169, and instead of dividing, I'm going to multiply by the reciprocal. And we're set, 120 over 119. So there's our three answers for sine 2 theta, cosine 2 theta, tangent 2 theta, and double check. They gave us theta in quadrant 4, so double that, it looks like, since my sine and cosine are negative, we'd either be in quadrant 3, right? I think we'd have to be in quadrant 3 if we doubled it. But the signs here should remain true. All right, so you guys can work on the next examples and just come flag me down if you have any questions.